This Zoom session is being brought to you by the Fractal Horizon Labyrinth A. For today, we'll be going 4.2 and 4.3, the law of sines and the law of cosines. And finally, we will be doing some actual trigonometry, which means triangle measurement. So, given a triangle has 3 angles and 3 sides, and generally the trig problem will consist of, given 3 of those numbers, what are the other 3? Now, this doesn't work in all cases. If you know 3 angles, you really don't know the sides, only their relative proportions. In any case, if you know 2 angles, you know the third by the angle addition rule, but still nonetheless. Now, a big one, law of sines. Oh, good one, big one. It's given, let's start off with a triangle. It'll relate sines of angles to their opposite sides. So let's say we have a triangle with angles alpha and beta, traditional Greek letters. Opposite alpha is A, opposite beta is B. And we drop this perpendicular with a height of h. Now, h over b equals sine of alpha. H over a is sine of beta. Therefore, transposing h equals b sine alpha and also equals a sine beta. So b sine alpha equals a sine beta. And then transposing the sine alpha and the sine beta, you get that b over sine beta equals a over sine alpha. This is an identity for triangles. Now, if a trigonometric identity is true, then it remains true if we swap the labels, alpha to beta to gamma to alpha, a to b to c to a. So we should also throw in c over sine gamma in this. So that's the law of sines. A over sine alpha equals b over sine beta equals c over sine gamma. Side over sine of the opposite angle is a constant for a given triangle. That's the law of sines. Now, given, therefore, 3 angles and a side c, so then we can solve for a, c sine alpha over sine gamma, b is c sine beta over sine gamma. So given 3 angles and a side, you can deduce the other 2 sides. AAAS implies SS. Now, because if you have 2 angles, alpha and beta, then we can deduce the third angle, gamma, as 180 minus alpha minus beta. Beta is 180 minus gamma minus alpha. Alpha is 180 minus beta minus gamma. So from 2 angles, you get 3 angles. From 2 angles and a side, you get all 3 angles. Ooh, that's a mistake. And all 3 sides. And from an angle side angle problem, you get 3 angles and a side. Excuse me, there's a small error to be corrected. Just a second, which is it? Okay, this is page 2, 4 to page 2. Triple A, not 4A. Yes, whatever. Okay, fine. And okay, so we can solve angle side problems given an angle and a side. We can also solve angle side angle problems. All right. So, for example, we have a triangle with 2 angles, 45 degrees and 25 degrees, and the side in between is 12.0. So what's A, opposite the 45 degrees? What's B, opposite the 25 degrees? And what's gamma, opposite C? Now, okay, first we need to find gamma to get all 3 angles. Gamma is 180 minus 45 minus 25, which gives you gamma is 80 degrees. And now, from A equals C sine alpha over sine gamma, A equals C sine alpha over sine gamma, which will be 12.0 sine 45 over sine 80, which comes out to about 8.616. B is C sine beta over sine gamma, 12.0 sine 25 over sine 80 is about 5.150. One nice thing about the law of sines is that once I wrote this down on my calculator to get A, to get B, all I have to do is recall the expression and then change the 45 degrees to a 25 degrees.
Excuse me.
Yes.
A triangle is 180 degrees, correct?
That is correct.
45 and 25 minus 180 is 110, right?
Let's let me double check there. You know what? Oh my goodness. 180 minus 45 minus 25. OMG, you are absolutely right. Gamma equals 110 degrees. All right, I am definitely, so okay, I should change that. So A is 12 sine, is it 45? Yeah. 12 sine 45 divided by sine of 110, huh? Oh, God. You got me good and hard. No, wait a minute, that can't be. Oh, wait, let me double check. I'll have to change. I have to make sure that's in degree mode. It's giving me a negative value. 9.029. Okay. And B is 12 sine 25 over sine 110 is 5.396. Oh, boy. So, okay. First, you got me good and hard. Excellent. Good. All right. The second problem. Let's make sure I have 47 degrees, 23 degrees, and the thirds and the side here is 51.2. Okay, what's B opposite this? What's this angle? Gamma, what's this side C? Okay, now let's make sure I didn't mess that up. Oh boy, minus 47 minus 23 is, that's 110. Okay, fine. So that's 110. So B is 51.2 sine 23 over sine 47, which comes out apparently to 27.354. Side C is 51.2 sine 110 over sine 47, which comes up to 65.782. Here we have something. Okay, here's one angle. I guess you might call it an angle of elevation, 25 degrees. You back off 1,000 feet. It's an angle of elevation of 15 degrees. So what's the distance from P to Q? Now, RPQ, this angle here is 180 minus 25 is 155 degrees. So this sharp angle here, PQR, is 180 minus 15 degrees minus 155, which comes out to 10 degrees. Okay, 10 degrees here, which is opposite the 1,000 feet here. And then this side we're looking for is opposite the 15 degrees. So PQ over sine of 15 degrees equals 1,000 feet over sine of 10 degrees. So PQ is 110 feet, 1,000 feet times sine 15 over sine of 10 degrees, which comes up to 1490.5 feet. I should say that that 0.5 is maybe one decimal place too many because you're only given this to, to the integer precision. But one excess degree of precision is okay. However, it's tempting the calculator to give you 9 degrees of precision, which is, of course, more than is really justified. Now, here we have another kind of angle. I call it, for politeness' sake, side-side angle, though it's usually written the opposite way around, which I won't repeat for obvious reasons. But I also call it the pendulum, because the idea is, okay, here we have an angle, a side, and a side. Okay, given alpha, given B, given A, find gamma, find beta, and find C. Now, sine beta over B equals sine alpha over A, and after a bit of transposition, you get that sine beta equals B sine alpha over A. Now the thing is, this could be bigger than 1. It could be equal to 1, it could be less than 1. If it's bigger than 1, then basically, I think of this as a pendulum at the end of a cantilever. And if you raise up the cantilever too far, the pendulum never hits the ground at all, and there are no solutions. That would be for sine beta being bigger than 1, there are no angles with sine bigger than 1. Sine is between, well, negative 1 and 1. If sine B sine alpha over A equals 1, then beta must be exactly 90 degrees. And this pendulum just scrapes the bottom and hits the base here at 1 point only. So there's only one solution. And if B sine alpha over A is less than 1, then the pendulum hits the ground in 2 places. So there'll be 2 solutions. Therefore, this problem, side angle, is also called the ambiguous case, because beta could be arc sine of B sine alpha over A for this sharp angle, or it could be its supplement, 180 degrees minus arc sine B sine alpha over A. So this solution or this solution. So for example, B is 5, C is 3, beta is 100 degrees. What's A, what's B, and what's gamma? All right, we proceed. We have B and beta. We have C, and so the opposite angle is gamma. And from the law of sines, B over sine beta equals C over sine gamma. After some transposing and so on, you get sine gamma equals C sine beta over B. Plug it in, 3 sine 100 over 5 is about 0.59088. 2 solutions. So arc sine of that. So to find an arc sine, draw this horizontal line at a height of 0.59088. And so you get 2 angle solutions, this angle here and this angle here. The sharp angle is arc sine at 0.59088, which is about 36.22 degrees. This obtuse angle solution is 180 minus that arc sine, which is about 143.78 degrees. So there's 2 solutions. And so to properly answer this, you should give both, you could do a table with 2 sets of answers. So beta is 100 degrees, B is 5, C is 3, gamma 36.22 here, or 143.78 here. Now you find alpha, and after that A. Alpha is 180 minus beta minus gamma. 180 minus these is 43.78 degrees. Okay. Here, curious thing. 180 minus 100 minus 143.78 gives you a negative angle. So we rule this out. What happens is that here this pendulum swings to behind this angle here. So we rule it out. It's not a solution. So really, this ambiguous case also includes a case where if this side is longer than this side, where the obtuse angle case doesn't apply. But given beta, gamma, alpha, B, and C, then A is B sine alpha over sine beta, and that'll be 5 sine alpha over sine 100 degrees. Plugging this in for alpha, 43.78, we get A is 3.513. So this is the solution. The other solution doesn't work. Or A equals 2, C equals 1, gamma is 100 degrees. What's that? Well, so we have C and gamma. We have A, we'll look for alpha. So after the transposition, sine alpha equals A sine gamma over C, which is 2 sine 100 over 1, which is 1.9696, bigger than 1. So there's no solution. So that's several cases of triangles that's found this way. So we can solve angle, side angle problems, angle side problems, although incorrectly in this case. I shall change it in the Canvas notes. And this side angle problems as well. All right, let's pause this.